Alright, and we're going to wrap up your Chapter 10 practice test for algebra here with problems 13 and 14. Problem 13, we're given a system of equations, and we're asked to solve the system pretty much using any method. And if we look at the system, it kind of looks like a mess here, because just about all the methods that we have aren't going to be very easy. I'm going to throw out graphing because I don't want to graph. Talked about that. Just not what I want to do. We can't use substitution either, because we don't have y equals something or x equals something. We almost do. We have 2y is equal to 4 minus 3x, but not y equals, so that's not going to work. And then we can't use addition because all of our terms aren't lined up. We have our y terms lined up, but then a plus is lined up with the equal sign, the 3x with the 4, and the 5 with the 3x, so that's not going to work either. So what we have to do here is kind of change some things around. And it looks like changing the bottom equation so that it looks like the top equation will be our best option. I want to use addition. But in order to do that, I need to get my x and y on the same side of the equal sign in the bottom equation. Because x and y are on the same side in the top, they are not in the bottom. So if I take this bottom equation here and I want to get x and y on the same side of the equal sign, what I'm going to do is add 3x to both sides. Taking the bottom equation, and I'm going to add 3x to both sides to get rid of this minus 3x. So when I do that, here's what I get. The top equation, notice, is exactly the same as the top equation from the original problem. The bottom equation is not the same. It's been changed. And it's been changed by adding 3x to both sides of the equation. So I added 3x to the right-hand side of this equation and the left-hand side of this equation, leaving us with just a 4, and then we have a 3x on the left-hand side, plus 3x. So now we have our y's lined up, we have our x's lined up, and we have our constant terms lined up. So now I can combine these so that some variables will go away. And what I'm essentially going to do is take the bottom equation and multiply it by -1, because if I add these together, they will not go away. It would be 4y, this would be 6x, and this would be 9. So I want this to be a negative. I want this to be a negative 2y. But if I make this 2y a negative by multiplying by -1, then I have to make this a negative and this a negative as well. And that's exactly what we have here. So notice we are starting with a problem with a system of equations. We still have a system. We still have a system. Nothing has changed. But something is about to, because now we can add these equations together and our y terms will cancel out, because 2y minus 2y is 0. Then we have this 3x plus a negative 3x. Well, that's 0 too. Then we have 5 plus negative 4, which is 1. So we got 0y plus 0x equals 1. 0y comes from the 2y minus 2y. 0x comes from 3x minus 3x, so they're gone. And the 1 comes from 5 minus 4. So really what we're left here is 0 equals 1. Well, that doesn't make any sense. So what does that mean? If we're solving a system and we end up with something at the end that doesn't make any sense, 0 equals 1, a false statement, what that means for this system is that there is no solution. There's no answer to this system. There is no x and y that satisfies both of the equations at the same time. And if we were to graph these lines, which I'm not going to do, but let's just say we did, they would never intersect. There's no point that they have in common, and there's no solution. And how do we look at that algebraically? When we get a false statement. We're solving the system and our variables start to go away and cancel out, because that's what we're trying to do with one of them, but we ended up getting rid of both of them in that time, and we get something that doesn't make any sense, then there is no solution. So 13 is no solution. And our last problem. Oh, great. Look at this. Ignore that, please. just for the time being. Just ignore it. That'll come into play at the end. So we have 2x plus 10y equals 4 and negative 4x minus 6y equals 6. So we have this system right here, and we're going to solve the system. And notice we're not going to use substitution because we don't have x equals something, we don't have y equals something in either of these equations. So we're going to kind of turn to addition, but if we try to add these equations together, nothing's going to go away because 2x and negative 4x are not opposite, 10y and negative 6y are not opposite, 4 and 6 doesn't really matter because those don't have variables anyway. So here's what I'm going to do. I'm going to take the top equation and multiply it by 2. Because ideally I want this right here, if I want to get rid of x's, I want this 2 right here to be a 4. Well, how do I make 2 a 4? I multiply it by 2 and I get 4x. The 20y comes from 10y times 2 is 20y. And the 8 comes from 4 times 2, which is 8. Now I can add these together. Although I could have added them together before, but now I can add them together and one of the variables will go away. Which one? X, because they have opposite coefficients. 4x and negative 4x are opposite, so that gives us 0. So what we're left here is 14y equals 14. 14y from the 20y plus negative 6y, and this 14 from the 8 plus 6. So if 14y equals 14, then y equals 1. Now that we know that y equals 1, we can go back up to one of the original equations and plug in 1 for y. So I'm going to plug it into the top equation. That's the one I want to work with because I don't want to deal with these negative signs. So 2x plus 10 times 1, why 1 and not y? Because y is 1. So 2x plus 10 times 1 equals 4. 2x plus 10 equals 4. Subtract 10 on both sides. So 2x equals negative 6 because 4 minus 10 is negative 6. And if 2x equals negative 6, that means that x equals negative 3. So the solution to this system is negative 3, 1. And the question was asking, are these lines coincident? Are they parallel? Or are they intersecting? And the answer to the question is that these lines are intersecting at the point negative 3, 1, which is why we have this right here. Sorry for having that show up earlier. So your solution is negative 3, 1. They are intersecting at the point negative 3, 1.